Imagine a whole brain trust of AI, like a dream team of masterminds, coming together to crack those really complex problems that we humans just kind of struggle with.
Yeah.
That's what we're going to dig into today. LLM multi-agent systems.
Right.
It's like, the old saying, two heads are better than one. But here, we're not talking about just two. We're talking maybe dozens of AI agents, each with their own sort of specialty, all collaborating.
Yeah, and it's interesting how this idea has been around. We've been using multi-agent systems for a while, like decades, in things like, think about air traffic control.
Oh, right.
Different systems managing different aircraft, or even supply chains where you've got agents tracking inventory, deliveries, that sort of thing. But this new wave with LLMs, large language models, it's like we're strapping a rocket booster onto it.
Okay, so unpack that analogy for a second. What is it about LLMs that's so groundbreaking in this context?
It's like this. Imagine instead of these rigid pre-programmed rules, these new agents, they're guided by language, by something called prompt engineering. You're basically giving the AI instructions in plain English, and it figures out the how-to and the why on its own.
Huh.
It's a huge leap in terms of flexibility and learning.
So they're not just blindly following a script anymore. They can actually adapt and respond to, like, the nuances of a situation.
Exactly. And what's making this even more accessible is there's something called the Assistance API from OpenAI. And it's essentially a toolkit that lets developers, even people like you and me, build applications using these multi-agent systems without having to be, coding wizards from scratch.
That's huge. So it's like you're opening up the power of this technology to a much wider audience.
Yeah.
But before we get ahead of ourselves, we got to understand, like, what even makes an LLM an agent in the first place? I mean, it's one thing to have these fancy language models, but how do they actually become active decision makers in a multi-agent setup?
Yeah, you hit it right on the head. We can't just be throwing that term agent around without really understanding it. There's a fascinating research paper. I'm going to butcher the Japanese title, but it translates to an overview of LLM agents, and it breaks it down into 4 key elements.
Let's hear it.
So first, you've got these psychological aspects, and, stick with me here, it might sound strange, but it's really about giving these agents the ability to kind of process information, make decisions in a way that at least somewhat resembles human thinking.
So it's not just cold, hard logic. There's an element of simulated, like, psychology in play here.
Exactly. And this ties into the second element, which is mimicking historical figures or even like fictional characters.
Yeah.
This is where it gets really interesting because researchers are exploring if these LLMs can embody different personas, different ways of thinking, different approaches to problems.
So you could have an LLM agent that acts like, I don't know, Sherlock Holmes, another one that's like a master strategist, and maybe even one that's a bit of a wild card.
Yeah, you got it. The third element, it's all about imitating real-world experts. Think doctors, lawyers, engineers, those agents that can access and process information like a specialist in that field.
So instead of replacing human experts, it's more like they're giving them AI assistance.
Right. Exactly, augmenting their abilities. And then finally, the fourth element. This is borrowing from the world of autonomous agents. It's that ability to act independently, to learn from experience, and then adapt strategies over time.
So it's like a blend of psychology, this character imitation, expert knowledge, and then that drive towards autonomous action. It makes you wonder, are these systems actually capable of real collaboration? Can they grasp that other agents, maybe even human collaborators, have their own thoughts, intentions, maybe even motivations?
That is the million-dollar question, and it leads us to this concept called theory of mind.
Ooh, now this is where it gets really interesting, at least for me. Theory of mind. Okay, that sounds like something straight out of science fiction. Are you saying these LLM agents might actually, like, understand what their fellow AI buddies are thinking?
It's a huge area of research, and yeah, some of the findings are kind of mind-blowing. There's this theory of mind for multi-agent collaboration via large language models. And it's just, LLMs, they're showing these early signs. Like in simulations, they're starting to show that they can kind of figure out what other agents might know or believe, which is, well, crucial for teamwork, right?
So it's like they're learning to anticipate each other's moves, not just react after the fact.
Exactly. Think of it like a chess game, right? A good chess player, they're not just focused on their own pieces. They're trying to get inside their opponent's head, think a few steps ahead. And that's what researchers are trying to replicate with these multi-agent systems.
That's wild. But let's be real for a second. We humans, we're not exactly the best at this whole mind reading thing either, We misunderstand each other constantly. So how can we expect these AI agents to get it right?
Well, that's the challenge, isn't it? Human interaction, it's messy.
Yeah.
So much nuance, all this unspoken stuff flying around. But even if LLMs can just grasp like a basic form of theory of mind, it opens up some crazy possibilities for collaboration.
Okay, so we've got these AI agents, maybe with this whole theory of mind thing happening. They're all working together in this system. But how does that actually play out? I mean, are we talking about AI teams that are always perfectly in sync, always getting along, or can things get a little, competitive?
Let's just say AI team dynamics. They can be just as interesting as human ones. Researchers are exploring a whole range of multi-agent setups, each with its own kind of quirks and opportunities.
Okay, you got to break this down for me. I'm hooked.
All right, so imagine this. You've got your collaborative setups, right? The agents are designed to work together toward a shared goal. It's a team of architects designing a building. One agent might be a structural whiz, another one's all about sustainable design, that sort of thing.
So instead of competing, it's like they're specialists pooling their knowledge.
Exactly. It's all about synergy, maximizing that combined brain power. But then you've got your competitive setups. This is where things get into game theory, negotiation, all that fun stuff. These agents, they might have goals that clash, and researchers study how they navigate those conflicts, how they learn to compromise, maybe even outmaneuver each other.
So like a high-stakes game of chess, but instead of moving pieces, they're making decisions, trying to predict each other's next move.
Exactly. And what's really cool is that the insights from these simulations, they can actually apply to the real world. Think about negotiating a trade deal or developing a military strategy or even just, resolving a conflict in the office.
It's like holding up a mirror to human behavior, but with this AI twist. But let's be real. The world is rarely black and white. We often need a bit of both, right? Cooperation, A&D competition to get the best outcome. Are there setups that capture that complexity?
You're reading my mind. There are these hybrid setups, and they try to mimic that messiness we see in the real world. Those are super complex because you've got agents that might cooperate one minute, then compete the next, all depending on what's going on. Think of it like a team of entrepreneurs starting a business. They got to work together to get the company off the ground, but they also might be, vying for leadership or a bigger piece of the pie.
Okay, so we've got these different setups: collaborative, competitive, and hybrid. But what have researchers actually learned about how these AI agents communicate, how they learn from each other? It's not like they're sending each other emojis or grabbing coffee to chat. It really is amazing when you think about it, trying to figure out how these AI agents are actually communicating. It's like they're speaking some secret language we don't quite get yet.
It's true. It's like we're trying to decode an alien language, but instead of weird sounds, it's algorithms in code. And one of the interesting things they've found is that a little bit of conflict, it can actually be a good thing. There's this study exploring collaboration mechanisms for LM agents, social psychology view, and they found this debate first, self-correction last approach that actually led to the most accurate results.
Wait, hold on. So you're saying arguing, like a good debate, can actually make these AI systems smarter?
Yeah.
Okay, well, that's kind of reassuring given how much we humans seem to love to debate.
Right. It's true. So in this setup, they encourage the agents to, challenge each other's assumptions, point out flaws, and then they work together to refine the answers. It's like having a panel of experts with different viewpoints, all pushing each other to think more critically.
Right, like that saying iron sharpens iron. But then again, too many cooks in the kitchen can also be a recipe for disaster. Does that same idea apply to these multi-agent systems?
Oh, for sure. Just like with any team, there's a sweet spot when it comes to the number of agents. The folks over at, Chedeval, towards better LM-based evaluators doing multi-agent debate, they found that too many agents can actually make things worse. Performance takes a hit.
So it's about finding that balance, just the right amount of different perspectives without creating too much chaos.
Yeah, you need enough to spark innovation, but not so much that you end up with confusion. But this is all theoretical, right?
Yeah.
The big question is, can these multi-agent systems actually escape the lab and do something real in the world?
Yeah, that's what I want to know. Are we talking about some far-off future, or are there things happening now?
Oh, they're already making waves. Remember that mad approach, the debate then correct thing? Turns out it's not just for research. It's changing how we build those question and answer systems.
So you're telling me the next time I ask my virtual assistant something, I might actually be getting an answer that was refined through a whole AI debate.
You got it. By using this multi-agent approach, developers are creating these Q&A systems that are way more accurate, more nuanced, fewer of those annoying errors that used to plague us.
That's wild. It's like they're giving these virtual assistants a serious upgrade in their thinking. What about other applications? What else can these systems do?
Another really promising area is running simulations, like role-playing different scenarios. Imagine testing out new laws, new business strategies, whatever, but in a virtual world before you roll the dice in the real one.
So instead of going with your gut or relying on limited data, you use these AI agents to sort of game out different possibilities, like a high-tech crystal ball.
Exactly. We're talking simulations in law, finance, you name it. AI agents could be lawyers arguing a case, or they could be simulating market trends to test investment strategies. And here's a cool example. There's this project called the Tango Multi-Agent Wizard GPT, and it lets you interact with these different AI characters, each with their own personality expertise.
Oh, wow. So it's like a choose your own adventure, but instead of a pre-written story, you're having a real-time conversation with these AI agents.
Exactly. It's a really fun, accessible way to experience what these multi-agent systems can do. And speaking of experiencing it, this tech is also set to revolutionize software development itself.
Now, that's something I've been wondering about. We've all heard about AI writing code, but are we talking about AI teams, like working together to build entire software programs?
That's the goal. Microsoft, for example, they've created this framework called AutoGen, and it's made specifically for building these multi-agent LLM applications. So you have a team of AI agents writing code, testing, even fixing bugs, all with minimal human intervention.
That is mind-blowing to think about. It's really incredible how fast this technology is moving, and it seems like we're really on the edge of something big here. But as with any new technology, there are always questions, maybe even some concerns. What are some of the challenges that researchers are still trying to figure out?
One of the biggest ones is figuring out how we humans and these AI agents, how we're going to best interact, collaborate. How do we learn to trust their decision-making? And how can we make sure these systems are used ethically? These are things researchers are working on right now, and it'll become even more important as they become more integrated into our lives.
It really feels like we're at the start of something brand new here. AI is not just a tool anymore. It's becoming a partner in problem solving, a collaborator in the truest sense.
And as we step into this unknown, this much is clear: the future of AI. It's not just about building smarter machines. It's about creating a smarter future for everyone.
That's a great point to end on. And with that, we'll leave you to ponder all the amazing possibilities. This has been an incredible deep dive into the world of LLM multi-agent systems. We'll see you next time.